Okay, so welcome everyone to this class. My name is Tutor Poul Solutions, okay, and I'll be taking you in this course, okay. So this course is Introduction to Probability, okay. So it has a code of Maths 2901, okay. So this course here is taken by all those who are doing actuarial science, okay, all those who are doing statistics, and others who are doing math, and those who are doing economics. Okay, they are minoring in math. They also take this course, and for those who are also taking what we call as geotech. Okay, so all these courses that I've mentioned, you guys will be taking this course. Okay, and this course is a very simple course, but it's demanding. Why? Because it's a half course. Okay, so meaning you write your exams in somewhere May there. Is it May or June? Okay. So meaning from the very start, you have to put in a lot of effort, okay? Because it's a half course, it will demand that you know this thing that we're going to be learning here at a very fast rate, okay? And because of that, some students tend to not to cope with that, okay? And they'll end up performing very bad in this course, okay? But by nature, this is a very friendly course, okay? You have to understand the definition that you've been given and then how to apply them. That's all. Okay. So if you don't understand the definition, then it will be a little bit difficult for you. But if you understand the definition, it will be very easy. Okay. So from the word go, you have to master the definition. So we are moving from the concept of where we are saying math is all about solving and the like. Okay, so when you come to this introduction to probability, now you have to master the theories. Okay, you have to understand the definitions just like that. Okay, so in this session here, I've outlined objectives that we are going to cover. Okay, so the first one, we are going to define what probability is. Okay, and then we look at what an experiment is, what a trial is, and what an outcome of this experiment is. Okay, from there, we'll look at what we call as the sample space and what we call as an event. Okay, then from there, the last thing we're going to look at is the probability of a certain what event. Okay, so we start from the first there. Okay, so our first uh, thing to do is to define probability. Okay, so what is probability in your own language? Okay, what is probability in your own language? What can you say? Anyone who can give us a definition of what you think probability is? What do you think probability is? Hello, guys. What do you think probability is? Anyone who can try? Is it the first time you are hearing the word probability? Okay, so by definition, we can simply say probability, okay, is simply how likely, okay, is simply how likely an event is to occur or to happen, okay? So simply how likely something is to happen is what we call as the probability, okay? So in many of the life situations, okay, many of the life situations, um, we are faced with uncertainty and what variability. So what does this mean? Okay, so whatever you do, there is a concept of probability there. So for example, we're just from writing uh, the exams, okay, and the results are coming out soon. So you have that uncertainty to say, maybe that course I didn't pass, okay, that course maybe I didn't do well. Okay, there's a possibility I might get this grade and that grade. Okay, so you have that uncertainty. Okay, so for you to measure that uncertainty, we are going to be using what we call as what? Probability. Okay, so this is just simply how likely something is to what? To occur or to happen. Okay, so we use probability in almost everything that we do. Okay, so that's the definition. So you must know this definition by heart. And then next, we look at what a random experiment is, or simply what an experiment is. Okay, so an experiment by definition is simply a mechanism that produces a definite outcome. Okay, so a mechanism that produces a definite outcome. That is what? An experiment. So for example, is tossing a coin. Okay, so when you get a coin, you throw it up, okay? You definitely know that you either get a head or a tail, okay? But you are not certain, okay, if it's going to be a tail or a head, okay? So you have a definite outcome, quite right. It's going to be either head or tail, but you don't know which one exactly you're going to what to get. So that's what we call as a random experiment. It's just a mechanism that produces a what? A definite outcome. Okay, and then talking about the outcome itself, okay, this outcome here is just the observed results, okay, of the experiment or from the experiment. Okay, so the thing that you'll be observing, okay, from your experiment, that's what we call as the what? The outcome. Okay, and then the performance of such an experiment is what we call as a trial. Okay, so the performance of such an experiment is what we call as a what? A trial. Okay, so any questions so far on those few definitions that I've given? Any clarity that you may need? Okay, wonderful. So I proceed to defining what a sample space is and what an event is. Okay, so when you conduct an experiment, and then you get all the possible outcomes of that experiment is what we call or refer to as the what? The sample space. Okay. So by definition, you can say the sample space is simply the set of all possible outcomes of an experiment. Okay. So if, for example, I get that example that I gave for tossing a coin. Okay. So if we toss a coin, we have two possible outcomes, right? It will land head, okay, or it will go to the tail. So when I get the set of this head and the tail, this here will be my what? My sample space. Okay, why? Because it contains all the possible outcomes of that specific experiment that I've done, which is in this case, we're tossing a coin. Okay, and then what is an event? Okay, so an event is just any subset of the sample space S. Okay, so from this tossing a coin, we are saying the sample space is this set that contains the head and the tail. Okay, so if I get any one of them, if I get just the head like that, okay, we see that this head is a subset of this guy here. Okay, so this subset of that sample space that we have is what we call as the what? An event. Okay, so these are very important definitions. Why? Because in all your problems, okay, regarding this probability, you always be given an event and a sample space, okay? Always. So Mufasa, you're writing on my screen. I don't know why. Okay, so that's what an event is. Okay. All right. So and then here I was saying if A is an event, then A has occurred if it contains the outcome that has occurred. Okay. All right. Okay, so we go to the next thing here, which is defining the probability of an event. Okay, so I know most of you guys know how to find the probability. Okay, so if you have 10 mangoes, no, not that example. Okay, say for example, we have a bag. Okay, and then in that bag, we have 10 red balls, and then we have 5 blue balls. Okay, and then they ask you what is the probability of getting blue balls from that bag. Okay, you're going to say the favorable outcomes, which will just be 5 for blue, and then the total number of marbles in that bag, which will just be what? 15. So your probability here will just be 1 over what? 3. Okay, so this probability of an event basically defines this definition here. So let S be the sample space, okay, of all possible outcomes of an experiment, okay. Then the probability of some event A is given by this definition that I've given here, okay. So probability of the event A is equals to the number of ways event A can occur divided by the number of possible outcomes that can come from that what? Sample space S, okay. So in short, the number of favorable outcomes that you want, okay? And then we divide it by the total number of what outcomes from that event. Okay, so here I was trying to give an example here. So this question in blue there, okay, they are saying given S contains 1, 2, 3, 4, 5, okay, find the probability of observing an even number. Okay, so what would be the probability of observing an even number? Okay, so we say the probability of even will just be equals to, okay, and then we pick how many even numbers we have in this set. Okay, so we can see 2, 4, and 6. So we have 3 numbers that are even there. So the probability of picking an even number in this set will just be what? 3 over 6. And then you reduce this, it will just be 1 over 2, which is the same as what? 0.5. So this is how we can use this formula for finding the probability of an event, okay, to find the probability, okay. So this will be a very important formula that you use throughout the course, okay. Whenever you want to find the probability of something, okay, you will be doing something similar to this. Okay, so if there are no questions, I'll proceed to our example for today. Okay, so based on the things that I've taught, okay, exam questions can come from there. Okay, so the first one there is example about writing the sample space or finding the sample space. Okay, so example 1 here they're saying find the sample space for the following experiments. Okay, so this question here, guys, looks simple, but I've seen people failing to give what the sample space is. Okay, so the sample space, we said, it's just um, the total outcome. Okay, the total outcomes from the experiment. So the first one here, the experiment that we have is a single coin is tossed. Okay, so if a single coin is tossed, what is the if a single coin is tossed, what is the sample space? Okay, so we know that if I have a coin here, okay, we have the head part, and then down there we have the what? The tail. Okay, so it means the number of outcomes that can come from me tossing a coin are just the two of them. Okay, it's either it lands on head or it lands what? Tail. So this one here is my sample space. So I indicate it with the letter S. Okay, so my sample space for this first one here is just H and T. Okay, and then number 2, so we've done number 1. Number 2 here, they're saying 2 coins are odd and are distinguishable. Okay, so meaning we can tell the coins apart, right? They are different. Maybe we get a 1/4 coin and a 5/4, the 1/4 coin and the 5 ngwe coin. Okay, so we roll those, we toss those coins. Okay, what is the sample space after tossing? Okay, so in that situation, you have 2 coins. So you have this coin, and then we have another coin there. Okay, so let me draw one of these in a different color. So maybe we have that green one, and then we have this yellow one here. So this yellow one can land head and tail. Okay, even this one can land head and tail. So what are we going to do in order to find the sample space? Okay, so when we toss these coins together like that, it's either both of them will land head head, okay, or one of these will land head and then the other one tail. So it will be head and then the other one tail, or it can be the other one tail, okay, the second one head, or it can be what? Tail, tail. So this here is our sample space, okay. So we are going to say our sample space S is just equals to, it's either it's HH, okay, or it's HT, or it's TH, or it's what? TT. So this here will be our what? Our sample space. Okay. So any questions here, or now we are getting the sample space? Any questions here? Okay, no questions. I will go to question 3 here. So on question 3, they're saying a single die is rolled. Find the event that corresponds to the phrase. Okay. And even number is rolled. A number greater than 2 is what? Okay, so for us to find these events, we first of all have to come up with the what? The sample space. Okay, so let's first find the sample space when this coin is, when this die is rolled. Okay, not a coin. We're dealing with a die now here. So we know that a die has 6 sides, right? Okay. It has the side where it has 1, 2, 3, 4, 5, and then 6. Okay. So it can land on either of those sides, on those numbers. Okay. So the sample space S will just be equals to the set that contains 1 to 6. Okay. So when you roll the die, it will either land 1, or it can be 2, it can be 3, it can be 4. It can be any of those numbers that are in this set. Okay, so this here is our sample space. Okay, and then now we have these extra questions here where they're saying find an event, okay, that an even number is what? Is rod. Okay, so the event that an even number is rod, we're going to say event is equals to, okay, we're just going to pick the even numbers here. So the event, remember, we defined as the event as a subset of the sample space. Okay, so the even numbers here are just 2, 4, and then 6. So this here is the event that an even number is what? Is rod. And then the second one here, they're saying find the event that corresponds to a number greater than 2 is rod. Okay, so when I come to this set here, I have 4 numbers that are greater than 2. So I have 3, 4, 5, 6. Okay, so this event on B, we're just going to say this is the event, okay, that contains 3, 4, 5, and 6. Okay, so this here is the event that a number greater than 2 is rod. Okay, so any question here on how we're coming up with those answers that we are writing? Any question? Okay, all right, so I'll proceed to example 2. Okay, so example 2 here, we have this question here. Very nice question. Okay, so this question here was in test 1. Okay, this question here was in test 1 last year. Okay, so they're saying the experiment consists of tossing 2 dice. Okay, find 1, the sample space S, and then 2, find the event that the sum of the dots on the dice equals 7. Okay, and then number 3, they're saying the event B is such that the sum of the dots on the dice is greater than 10. And then C, we have the event C, okay, such that the sum of the dots on the dice is greater than what? 12. Okay, so how can we solve this question here? So remember here we've been given 2. Okay, so we are tossing 2 dice. Okay, so meaning I have the first die here and then another one there. Okay, so we are tossing them at the same time. Okay, so what um, is going to happen if you're tossing them at the same time? So how do we find this sample space? So this sample space here, okay, so we are finding 1 here. We are going to combine, okay? We're going to combine the sample space of the first die to the sample space of the second die. So how do we do that? Okay, so we're going to write the sample space of the first die in a row like that, and then the sample space of the second die in a column. So we are going to say the first die there, we know that the sample space, it can either be 1, 2, it can either be 3. Okay, let me reduce this a little bit. It can either be 1, it can be 2, it can be 3, it can be 4, it can be 5, and it can be 6. Okay, so this is the sample space of the first die. Okay, and then the other die also has its own sample space. So it can be 1, it can be 2, 3, 4, 5, okay? And then we have 6 there at the end. So I write 6 there, okay? So what will be happening is this, okay? When I roll these dice here, okay? So I think I didn't write 1 for this guy, so I should write 1 for this guy. Okay, I didn't write 1 for this guy, so so you put 1 here, 2, 3, 4, 5, and then 6. Yeah, like that. Okay. So when you roll this first die, and then you also roll this second die at the same time, it's either they are both going to land on 1. So you're going to have 1, 1 here. So this is not 11, it's 1, 1. So we have 1 from the first die, and then 1 from the second die. Okay. What about if the first die is 2, okay, and then the second die is what? Is is um is 1. Okay, so it means we are going to have 1 and 2 there. Okay, here we're going to have 1 and 3, here to be 1 and 4, 1 and 5, 1 and 6. Okay, so we'll continue just the same pattern here. So it means in this row here, it will be 2 and 1, 2 and 2, 2 and 3, just like that. So it will be 2, 1, 2 and 2 there. Okay, 2 and 3, 2 and 4 there, and then 2 and 5, and then 2 and 6. For these 3, it will be the same pattern, to be 3, 1, 3, 2, 3, 3, 3, 4. Okay, let's write that 4 properly. So we have 3, 4, then 3, 5, 3, 6, okay? And then here we have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and then 4, 6. Okay, let's write the one for the 5 to be 5, 1. We're just following the same pattern, 5, 2, 5, 3, 5, 4. And then 5, 5 will be there, and then 5, 6. Okay. And then here it will be 6, 1, 6, 2, 6, 3, 6, 4, 6, 6. That's 6, 5, right? With 6, 6. Okay, so write 5 there. And then here it will be 6, 6. Okay, so whatever I've drawn here will be our sample space. Okay, so we're going to say sample space is equals to this whole thing here. Why? Because we are rolling 2 dice at the same time. Okay, so we have 2 dice at the same time, and these here are the possible what? Uh, Combinations that you're going to get. Okay, so this is the sample space. So we've answered the first one. So now to answer the second one here, they're saying find the event A such that the sum of the dots on the dice equals 7. Okay, so you just want to pick numbers here, okay, such that when you add them, remember these are not 32s, 23s, no, they are 1, 3, 2, 3, just like that. So we want to pick numbers from this sample space here, such that when we add them, okay, they're going to give us what? 7. Okay, so which numbers can we add so that we get 7? Okay, so we see that we can add 6 and 1, we can add 5 and 2, we can add 4 and 3, we can add 3 and 4, we can add 2 and 5, and we can add what? 1 and 6. Okay, so find the event A such that the sum of the dots on the dice equals 7. Okay, so we are going to pick this here: 1, 2, 3, 4, 5, 6. Okay, so that event there will just be 6 over the total number of outcomes here will just be what? We have 6 columns and 6 rows. So the total number there to be 6 multiplied by 6, 36, right? Okay, so it means, okay, let me create some space here. So it means that for us to find this first one here, the event that the sum is 7 there, okay, it's just going to be equals to, okay, so the probability of it being 7, the event being 7 is just equals to, how many do we have? We said 1, 2, 3, 4, 5, 6. So it will be 6 over what? 36. And then you divide. Okay, so 6 into 6, it is 1. 6 into 36 to just be what? 1 over 6. So this one here is the event that the sum of the dots will be equals to what? 7. Okay, so any questions there?
Yes.
Yes.
Yes, sorry, I just needed clarity. So in this example, when finding the event A, you found the probability. But in the previous question, question 3, when they asked for the event, you put the answer in brackets.
Yes.
So how what's the difference?
Okay, so usually then when they ask like this here, they are asking for the probability here. So the first thing that you can do is first list these these numbers that we've circled here, these pairs that we've circled, okay, you list them as an event, and then you find also their probability there.
Ah, okay, okay.
Yes. Okay. All right. And then the other one they're saying find the event B, okay, that the sum of the dots is greater than 10. Okay, the sum of the dots is greater than 10. So what are we going to do there? Okay, so we look for numbers that we can add such that their sum is greater than 10. So which numbers can we add that are greater than 10? Which
Six,
numbers can we add?
six,
Huh?
6, 5,
Okay, so we can add this 6 and 5. This will be greater than 10. We can also add this 5 and 6. It will be greater than 10. We can also add 6 plus 6. It will be greater than 10. Okay, so that event will just be equals to, okay, so the question that the previous asked, you can first list them like this. Okay, what is happening to my pen? Okay, uh, just a minute. My board is misbehaving. Okay, so let me get back the board. Okay, so board. Okay, hide board and then go back to Zoom. Okay, so I don't know what happened to the board. Okay, but I'm sure you can see it now, right? Can you see my board?
Yes.
Yes, sir.
All right. Okay, so what I was saying is we are finding the event such that uh, when we add those two numbers, they are going to give us a number that is greater than what? 10. Okay, so the first one that we have here will just be this 6 and 5, and then we have the 5 and 6, and then we have the 6 and 6 there. Okay, so the event you can list it out if you want. Okay, so you can say 6, 5, 5, 6, okay, and then 6, 6. And then now you find the probability of this event. We're going to say how many are these? They're just 3. Then we are dividing by the total, which is what? 36. Okay, so the final answer here will be 1 divided by 12, like that. Okay, so that will be the answer there. So unless there are other questions, okay, so if there are no questions, I'll solve the other one. Okay, so the other one now there we have the event C, okay, such that the sum of the dots on the dice is greater than what? 12. Okay, so do we have a sum there that will be greater than 12? Hello? Do we have a sum there that will be greater than 12?
No.
No.
No. Okay, so this event here is empty. Okay, doesn't have anything inside. So it means the probability of this event C happening, it will just be 0 over what? 36. So this will give you a probability of what? Of 0. Okay, so any questions there? Any questions? All right, so that's it for this class. I just wanted you guys to be introduced to to some of these terminologies, okay, like the sample space, the probability of an event, and then all those event terminologies that we've defined in this class. Okay. So if there are no questions, I'll end my class here. So this was just the introduction. Okay, so thank you so much for attending. We'll continue the classes tomorrow. So tomorrow we have Math 2200. Okay, so Math 2200 is linear algebra. Okay, so you are expected to learn all about matrices. Okay, so everything that you'll be doing in this course will be involving matrices. Okay, addition, subtraction, whatever you do. Okay, the application part of it, it will be what? Matrices. So this course, the ones who take it are those who are doing statistics, actuarial science, math, those who are doing geography with education, ICT with education. Okay, you will be learning this course called linear algebra, Math 2200. Right. So thank you so much and have a blessed night, guys.